Hello, everyone. Today we're going to have a look at some unusual uses of coordinate geometry in order to find things out. A lot of these things you will know from the junior cert. So the three things we're going to have a look at today are going to be. So I'm just going to get this light a bit better. So great. Hopefully that's better. Yeah, that's a little bit better. So today we're going to have a look at three things. We're going to have a look at the centroid. Okay, so some of you might be familiar with that term. We're going to have a look at the Circumcenter. Okay, and the third one we're going to have a look at is the Ortho Center. Now, if you did your junior cert honors, you probably came across some of these at some stage, but obviously we'll give you a quick refresher. So one of the things we know already from coordinate geometry is how to find midpoint. Okay, and a lot of these either require you to find the midpoint of a given line segment, or to find a perpendicular bisector, or to get a perpendicular line or something like that. So there's nothing here that will require us to learn anything new. More a case of it'll help us figure things out. So we'll have a look at the centroid first of all. So what the hell is a centroid? Well, for anyone doing physics, the centroid is the center of gravity of a two-dimensional structure. But in the case of a triangle, the centroid is got by getting the midpoints of the three sides, or any two sides will work, and then projecting a line through the midpoint of a given side to the vertice of the opposite side. And when you do that, what you get is the centroid. Okay. So they're basically the medians. They're lines that go through the middle of another side. Okay. So there's a little trick. If you know the three sets of coordinates that form the vertices of your triangle in this case, then you can find the coordinates of the centroid pretty easily. It's actually very similar to the midpoint one. Instead of x1 plus x2 over 2, it's x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. Okay, so it's just a quick way to find that coordinates if you know everything else, and then vice versa. If one of them is missing and you know that one, you can, just like you did with the midpoint form, you can back it back in and figure it out pretty easily. And the same with the ratio formula. A little bit of algebra and you'll be fine on that one. So that's what the centroid is, and that's what it does. The Circumcenter, again, one you would have done before. The Circumcenter allows you to draw the circumcircle. Okay, so for those of you who don't remember it, okay, again, you find the median point, okay, but you project a perpendicular line from the median point, and you do that in one other location, and where they meet, that should create the center of a circle that touches the three sides. Very badly drawn, but that's the idea. So that's going to be the circum, CENTRB. Okay. So again, you need to find the median, find the middle point. So once you found the midpoint, a perpendicular line drawn through that, so the two of them should intersect. So that's the key there, you see. So if you know the slope of this line and the slope of this line, you've got the slopes of the perpendicular bisectors. And if you've got the perpendicular bisectors and you get their equation, you can just do a simultaneous on the equation to find the circumcenter. So it's another kind of way. And then the third one, the orthocenter. So the orthocenter is very similar to this one, okay, but instead of finding the median, it's actually the only one that doesn't use the median. What you're doing is you're taking a perpendicular that goes through the vertex. So like that. So it's not necessarily on the median, but it does, whatever perpendicular to this line, it must intersect with this point. In other words, that vertex. Okay? So that would be the ortho center of that. Okay? So there are three bit of unusual ones, but again, like anything else in honors maths, they're there to make you have a bit of fun with them, in other words. So we're going to do a few of these. We're going to try and find some centroids and some orthocenters and just have a bit of fun and see, can we use the knowledge we have already? Remember, at the moment, we have all the knowledge from the junior cert for all the different formulas, plus we have the ratio formula, and now we have this quick centroid one if you know all 3 points. So we have a built-up kind of store of knowledge to be able to find any of these from any information that's given to us. So we're going to give this a go. Okay, so you can pause and rewind this if you need to kind of visualize what we're actually looking for. So remember, centroid, all you're getting is medians, and then project a line from the median to the opposite vertex. And that is where they intersect is your centroid. Or else use the formula if you have all 3 coordinates of the vertices. Okay, the circumcenter, you're finding the center of a circle that touches the 3 vertices of a triangle when it's made. How do you get it? Medians perpendicular. Perpendicular bisectors through the median. Okay, and then the orthocenter, it's the opposite of this one. We're not looking for the median, we're looking for a perpendicular line that goes through the vertex. So they don't have to go through the vertex, but they do. That's the real difference between those two. They're very similar, but not exactly the same. Right. So let's have a go at this. Let's pick a triangle. Okay, triangle has sides A, -4 and 3, B, 0 and -5, and C, 3 and 4. And we want to find the centroid. We want to find the orthocenter. So remember, centroid, we can use the formula, I think, because we have all 3 bits of bobs. The orthocenter, that's the one, the third one where we have the perpendicular bit. So let's work out the first one, the centroid. Okay, so centroid, we need x1 plus x2 plus x3 over 3, comma, y1 plus y2 plus y3 over 3. x1, y1, x2, y2, x3, y3. Okay, so that's going to give me -4 plus 0 plus 3 over 3, comma, 3 minus 5 plus 4 over 3. That gives me -4 plus 3 is minus a third. And 5 minus 5 plus 7 is 2/3. Okay, so again, like we were doing with the ratio ones, a good chance a lot of these will be fractiony, but they won't be the world's worst fractiony type of ones. Okay, sorry, I'm just trying to lift that up, but let's see, can we get there? Yeah, there you go. You can see it there now. Okay. You can always twist that there. Yeah. So that's the first bit done. Now the second bit. So let's try and visualize this, because I think for that one, it's pretty easy to be able to do without visualization. But for this one, I do think you need that kind of visualization. So let's just do a quick little visualization. It doesn't have to be accurate. Okay. Not at all. So -4 and 3 is going to be kind of top lefty. Okay. 0 minus 5 is going to be down here, I'd say. And that leaves you with a positive one top righty, 3, 4. Now these aren't accurate, but they're kind of in general where they should be in relation to each other. If you did a quick XY axis, you'd see that this is top. It's in the first quadrant, second quadrant, and that's in the, halfway between the third and the fourth quadrant down there. Okay, it's on the y-axis. So that's what we've got going for us. So what do we need? We need to find the orthocenter. We need a perpendicular line that intersects with one of these. Okay, so if you think about it, let's pick this one. We need a line goes like that. Okay, so we need the equation of that bad boy there. Okay, and similarly, I don't think any of the other ones, we're going to need one that intersects like that. So we've got a bit of work to do here, but it's all junior cert work. We need to get the slope of that line and then get its perpendicular. We need to get the slope of this line, get its perpendicular, and then using the slopes with those vertices, get two equations, find the intersection point, bing, bang, boom, you've got yourself an answer. So let us do this thing. Let's get the slope of this line. Okay, so x1, y1, x2, y2. So very quickly, y2 minus y1 over x2 minus x1. That's going to be 1 over 7. Okay? So that's 1 over 7 is its slope, which means this slope is minus 7. So that means I'm going to use this slope with this point in y minus y1 is equal to m on x minus x1. Y minus minus 5 is equal to minus 7 on x minus 0. Y plus 5 is equal to minus 7x. That's 7x plus y plus 5 equals 0. That's him done. So I'm just going to color him red and then color this line red. Okay, so that's him done. Okay, so I'm not going to waste any paper, so I'm going to do the other one here. So we need to get this equation, which means using these set. So I'm just going to call them x1, y1, because I already have an x2, y2 done. So it's going to be y2 minus y1 over x2 minus x1. That's 9 over 3. Okay, so let's say 9 over 3, which is 3. 9 over 3, which is 3. So if this is 3, then this one is minus a third. So now I have minus a third. And I have minus 4, 3. That's my x1, y1. Y minus y1 is equal to minus a third. X minus minus 4. Bottom left, top right, 3y minus 9 is equal to minus x. Now, let's be careful. Minus 1 times x is minus x. Minus 1 times plus 4 is minus 4. Bring them both over. X plus 3y minus 5 equals 0. That's purple. Purple. Okay, I'm going to move this up a teensy bit so everyone can see it. So here I have my two equations. So very quickly, let's do 7x plus y equal to minus 5. And let's do an x plus 3y equal to 5. So your choice. I'm just going to multiply the top line by minus 3, get rid of the y, solve for the x's, and bing, bang, boo it back in. Okay? So multiply the top line by minus 3. So that's minus 21x minus 3y is equal to 15. So that gives you minus 20x is equal to 20, x is equal to minus 1, therefore y is equal to 2. Yeah. So my point is minus 1 and 2 for my orthocenter. Now that is nothing but junior cert honors, but there's a hell of a lot in it there, lads. And you have to be able to visualize it. If you can't visualize it, you're either pretty good at your math or you're going to get it wrong. Okay? One of the two. So that's the idea behind them. Personally, that's the hardest one to do. If you think back to the other one, I'm just going to flick back over to the Circumcenter. That's actually not too bad. If you think about it, it's the same method as this, except you're just going through the midpoints. So you have a bit more to kind of go on. You're just getting a midpoint with inverted slope or perpendicular slope, and then you do your y minus y1 is equal to m on x minus x1. So